We're going to do some review here, lessons 3.4 through 3.7. If you look at page 167, some of the stuff on here is stuff we've already talked about from earlier in the chapter, but we'll go look at a few things here. If you look at the vocabulary, we're going to go to number 2. Number 1 was an exponent. That was from the first part of the chapter. Number 2, a letter or symbol that represents an unknown quantity, and that would be a variable. And number 3, we've already talked about, that would be a factor tree. Least common multiple, that was from the first part of the chapter as well. If you look at number 7, they want us to write a Y for yes if the terms are like terms, and an N for no if they are not like terms. So if you look at number 7, part A, we have 3A plus 3Z. The numbers are the same, but that's not really what we're after for like terms. We're looking at the variable parts. So we have an A and we have a Z. Those are different variables, different letters, so those are not like terms. Part B, and these, the variables are the same, so those are like terms. They could have written this as 1/3 x plus 1/4 y. Remember, you can put a 1 in front of the x, and then that x you can kind of just slide over to the side if you want. Either way, those are like terms. And if you look at part C, first term has a J, second term has a J, and third term has a J, so those are like terms as well. The bottom of the page talks about simplifying this expression. In order to simplify this expression, one of the things you could do is actually inside the parentheses, those are like terms. Those both have the letter Q. That second one doesn't have a number. You can put a 1 in front of that, and you can go ahead and combine those together. So 3Q minus 1Q would be 2Q, just like 3 minus 1 is 2, same idea. And then we're going to multiply now. So 4 times 2Q. You might think with the parentheses it's distributing. It's kind of like that. It's just that we only have one term that we're distributing to, if you want to think of it that way. So that would be 8Q. On the Q's, I like to put kind of this curl on the end of it. Otherwise, without that, very easily can look like a 9. If you look on page 169, we are looking at some things here for lessons 3.4 and 3.5. So they're wanting us to write algebraic expressions that represent these situations. So number 1, it says 22 less than 5 times the number f. Okay, so we'll start with the for sure part here. 5 times the number f, that would be 5f. If you want to put parentheses around one of those, or if you want to put a dot between them, you can. Just remember not to use the multiplication symbol, because that looks like the variable x. The deal is we want 22 less than this. So 22 less than the 5f, we're actually going to subtract 22 from it. So it would be 5f minus 22. Number 2, 48 times the number of game markers G, that would just be 48 times G, or 48G. Number 3, the number of eggs E divided by 12, that would just be E divided by 12. And then 3 times the sum of M and 7. Actually, we're going to want the M plus 7 in parentheses. We want 3 times whatever that sum is, so the M plus 7 would need to be in parentheses on that one. If you look at the next part, they want us to evaluate these expressions. They're telling us what numbers to put in place of the variables, what numbers to substitute in place of the variables, and then we're going to work those out using order of operations. So if you look at number 5, they want us to substitute a 4 in place of x. And then order of operations, we would multiply before we would subtract. So 12 times 4 is 48. And then 48 minus 7 is 41. Number 6, x is 4 and y is 8. So we're going to do 4 squared divided by 8. Order of operations, we do exponents before we divide. So 4 squared, which means 4 times 4. That would be 16. And then 16 divided by 8 is 2. Number 7, we're going to substitute in z is equal to 1. So 5 times 1 plus 3 times n is 7 minus 1 cubed. So we have parentheses here, but there's nothing going on inside of them. There's no operations happening inside those parentheses. So we're going to move to our next step, order of operations, which is exponents. We do have an exponent here, which is 1 cubed. 1 cubed just means 1 times 1 times 1, which would be 1. And then we have multiplication and subtraction. So multiplication is going to come before subtraction, and we're going to multiply going from left to right. So first of all, 5 times 1, which is 5. And then 3 times 7, which is 21. And now we're left with adding and subtracting. So adding and subtracting, we work our way from left to right. So 5 plus 21 is 26, and then 26 minus 1, which is 25. And I know that takes a little bit of writing to get through that, but it's really good if you're organized with your work and just do one thing at a time. If you try and rush through or skip steps, then you're more likely to make a mistake. Number 8, same idea. We're going to substitute numbers in. So y is equal to 8, x is equal to 4, n is equal to 7, and z is equal to 1. So similar idea, we're going to do the exponent first here. So 8 times 8 is 64. Now we're looking at multiplication and division. We're going to go from left to right. So we actually go ahead and do 64 divided by 2. And that's what I was talking about, not rushing. You don't want to just go ahead and say, oh, I'll just go ahead and multiply these other numbers. Then you get the wrong answer on this problem. 64 divided by 2, if you work that out, that would be 32. And then 32 times 4, if you work that out, is 128. Three times 7 is 21. And then we'll add and subtract from left to right. This would be 149 minus 1, which is 148. Lesson 6 was on generating equivalent expressions, so we were trying to figure out whether expressions are equivalent. One way of doing that is by simplifying them. Another way was by substituting numbers in. So if you look at the table, the method they're using here is by substituting. So first of all, they're saying we take this first expression and we put a 1 in place of the y. So 2.2 times 1 is 2.2. Still in the parentheses, if we add those numbers, that would be 3.2. And then if you multiply 5 times 3.2, that would end up being 16. And then 16 minus 3 is 13. I'm not going to nearly have enough room to work all these out, so I'm just going to write the answers, and then you can ask if you have questions on any of these. Definitely would want some scrap paper to be working these out. If you put a 2 in, you should get 24. You put a 3 in, you should get 35. For the next expression, if you put a 1 in, you get 15, and then 25 and 35. And then for the last one, if you put a 1 in, you get 13. Put a 2 in, you get 24. Put a 3 in, you get 35. The deal is, if they're equivalent, they're going to have the same value for any number we substitute for the variable. So if you'll notice, if we put a 1 in, we got 13, 15, 13. Well, that middle one's already out. It can't be equivalent because it already has a different value than the other two. So it's not going to be equivalent to the other two. So let's check these first and last ones out. They both have 24s here. They both have 35s there. It says circle the expressions that are equivalent. So I guess that wasn't a very good circle. But anyway, the first and third ones there would be the ones that would be equivalent. If you look at this next part, they want us to tell whether these are equivalent or not. We're going to make a slight modification here on this first one. We're going to go ahead and change these all to addition. So seeing if these are equivalent, I'm just going to bring this over to the side so I've got some room to work. We're going to look for some like terms. So we've got here a 10x plus 2x, which would be 12x. And then we've got a 3 plus 5. 3 plus 5 is 8. At that point, those are not like terms, so we'll just leave it that way, 12x plus 8. The second part, we can distribute over here, so this would be 4 times 3x minus 4 times 2. 4 times 3x is 12x, minus 4 times 2 is 8. So the first one, with our modification, we had 12x plus 8. The second one, 12x minus 8, so these are not equivalent. Number 3, the first one's already simplified. The second one, if you distribute that, that would be 9y plus, this would be 9/3 if you just multiply straight across. And 9 divided by 3 is 3, so that would be 9y plus 3. The other one was 3y plus 3, so those are not equivalent either. And then on number 4, the first one we can distribute. So 6 times 3x plus 6 times 1. That would be 18x plus 6. And then the second one, we can combine our x's. That would be 18x plus 6. So those are equivalent. The next part, they want us to use properties of operations to complete the equivalent expressions. So for number 5, they're wanting us to distribute. So that would be 2 times x plus 2 times 4. So that would be 2x plus 8. Number 6, we're distributing, or we're not distributing, we're factoring. If you look at 5 and 45, they're both divisible by 5, so they're factoring a 5 out. It's kind of the opposite process of distributing. So what we're going to do, we're going to think about 5 times what? That would give us 5x, and that would just be x, or if you want, you can put a 1x. And then minus 5 times what equals 45, and that would be 9. A way of checking this is just to distribute and make sure that you get 5x minus 45 that we had to start with. And then number 7 would just be distributing. So 3 times x plus 3 times 7 would be 3x plus 21. Lesson 7 was on simplifying algebraic expressions. If you look at number 1, we've got some y terms. What we need to make sure we remember is the sign to the left goes with the term. So this is like 9y minus 6y, which is 3y. and then we just bring the plus 4. Number 2, we've got 3x plus 7x, that would be 10x, and we bring down the plus 5. Number 3, we've got 8x minus 3x, would be 5x, and then we've got 13 plus 9 would be 22. Number 4, you can put a 1 in front of the x squared, or in front of the y squared. Those both have y squared, so they're like terms. 1y squared plus 3y squared would be 4y squared. Number 5, we've got 4x minus 3x would be 1x, or just x if you want. And then we've got 15 plus 10 would be 25. So 1x plus 25, or just x plus 25. And number 6, these are all like terms. 10x plus 2x would be 12x, and then 12x minus 12x. It's 0x, but really 0 times anything is just 0, so we could just say our answer is 0 for this one. One other thing to mention on these lessons is a little bit of vocabulary. So for example, if we had this expression, you could be asked about what parts are the variable, the quotient, the coefficient, and the constant. So the variable is going to be the letter that's representing a number. So x is going to be our variable here. If they ask about a quotient is a division problem. Remember, DQ, division, quotient. So 9 divided by 3 is going to be a quotient. Coefficient is a number that a variable is being multiplied by. So 7 is our coefficient. And then a constant is just a plain number that doesn't have a variable with it. So 4 would be our constant. Another thing they could ask you is how many terms there are. So terms, they talked about in the book as being separated by addition or subtraction. So this would have 3 terms. It has 3 terms, which would be 7x, 9 divided by 3, and 4. So this gives you an idea of what we're looking at in lessons 3.4 through 3.7. Have a good day.